and welcome back to Teacher Gimble's channel. Today we'll be going over Illustrative Math, Geometry, Unit 1, Lesson 9. I believe it's our last lesson on construction, so let's have fun with it. If you like this video, please make sure to like and subscribe with the button you can find all the way down at the bottom corner of this video. Let's get started. Problem 1. Which construction can be used to determine whether point C is closer to point A or point B? So for this construction, I'm assuming I've got 3 points hanging out. We've got point A, B, and C. And we don't really know if C is closer to A or C is closer to B. So we're going to try each of these things and figure out which one works to figure out if C is closer to A or B. Option A, construct triangle ABC. Okay, I did that. Basically, that's supposed to be on B. That doesn't tell us anything about it being closer, so cross it out. Let's try the next one. Oops. Cross it out. Construct a line perpendicular to segment AB through point C. So in this case, we have segment AB. We constructed a line perpendicular. I don't think that helps us either, so not particularly useful. What about C? Construct a bisector of angle ACB. So in this case, we have angle ACB. We draw circles, we do our bisector, we bisect it. That still doesn't tell us anything about the distance between C and A or C and B. In D, let's hope this is our correct answer. Construct a perpendicular bisector of segment AB. So I have AB. I'm constructing a perpendicular bisector. Comes down. I know this segment is the same length as this segment. And what I also know is that any line on this segment is equidistant from A and B, which tells me if C is on the left of this line, it's going to be closer to A, and if C is on the right of this line, then it's closer to B. So D would be our correct answer. Now, if you're not familiar with the fact about perpendicular bisectors, the points on that being equidistant from the point of the line that it is bisecting, I would go back to some of the earlier lessons to review that. All right, let's go on to the next question. Problem 2. Let's move myself over. The diagram is a straight edge in a compass construction. Lines L, M, and N are all the perpendicular bisectors of the sides of triangle ABC. Select all the true statements. So we have lines L, which is this guy, lines N, which is this guy, and lines M, which is that one. And they're all perpendicular bisectors. So it's bisect here. We're bisecting the sides of triangle ABC. So that's bisected, bisected, and bisected. Let's look at our options. Point E is closer to point A than it is to point C. So now something that we're going to go over real quick, because this also is in the next question. When we have 3 perpendicular bisectors like we do, and then they all meet in this middle point, what we're doing is we're separating our triangles into 3 separate areas. So we've got the blue area, the pink area, and the yellow area. Now the points in the yellow area, any point in the yellow area, the closest vertex is A. Any points in the pink area, the closest vertex is going to be C. And any points in the blue area, the closest vertex is B. So it segments the triangle into 3 sections, and we can figure out the points closest to the vertex based on which section they're in. So point E, we know is closest to B because it's in the blue section. So is E closer to A than it is to C? Well, we're not actually given information about that, so we don't know. So we're not going to mark that as correct. Is point L closer to point B than it is to A? Well, it's in the blue section, so it's closest to point B. So yes. Is point D closer to point B than it is to point C? Is D closer to B than it is to C? Well, let's look at our perpendicular bisector because I see it's on the perpendicular bisector, which means it's going to be equidistant. So this one over here is not true. And let's take a second and recheck E real quick, A, because I think we might have made a mistake. So is point E closer to A than it is to C? This is the perpendicular bisector, which means if we're on this line, we're the same distance from A to C, because this line perpendicular bisects AC. E is on the side with C, which means it's closer to C than it is to A. So this is still wrong. Cross it out. But it's always good to identify if you've made a mistake by going too quickly and just going ahead and double checking your answer. D. Point J is closer to point A than it is to point B or point C. So J is, where is J? I think we might have covered J up. So let's do some erasing. J is in the middle. J is actually going to be equidistant to each of the vertexes. So we don't know if it's closer to A, point B, or point C. Well, we do know. We know that's all the same. So that's not correct. E. Point K is closer to point C than it is to point A or B. It would be in this pink section. That's no longer pink. So yes, this is true. And F. Point L is closer to point C. Is L close to C than it is to point A or B? Well, we know L is closest to B because it's in the B section. And so, no, we can't necessarily say that L is closer to point B. And let's just double check that we have all of our sections. Yep, those are the correct sections we have. So no, this is wrong. I wanted to double check because you've got those double lines over there. So I just wanted to make sure that when we're looking at the three bisectors and the different segments they make. So when you have lots of extra lines, you always got to be careful that you're not making mistakes here. But this is our one segment, and this would be our other segment right here. And L falls within the B category, so we know that it's closest to B. All right, pause the video if you need a second to go over this as we go on to the next question. Problem 3. Decompose the figure into regions that are closest to each vertex. Explain or show your reasoning. Well, we just learned that if we perpendicularly bisect each side of the triangle, let's do a little farther, perpendicularly bisect this guy, perpendicularly bisect this guy, we end up having 3 separate regions. This guy is the A region, this guy is the C region, this guy over here is going to be the B region. And we can do the same thing right here. We end up with this region, which is closest to D, this region that is closest to C, and this region over here that is closest to B. So we can actually combine these 2 regions. So these are the regions that are closest to C, and these are the regions that are closest to B. These are the ones that are closest to D, and the ones that are closest to A. And that's it. So that's how you identify the regions that are closest to the vertex. Let's go on to the next question. 4. Which construction could be used to construct an isosceles triangle ABC given line segment AB? So we have AB. And let's just quickly do each of these constructions to figure out which one's the right answer. Mark a third point C, not on segment AB. So we have segment AB. We mark a third point C, draw AC and BC. There's no way that this is definitely isosceles, so nope. B. Label point C on segment AB. Construct a line perpendicular to AB through point C. So I drew point C here this time. So let's get rid of that one. I drew a line perpendicular through C. Draw segments AC and BC. AC is right here and BC is over there. That one doesn't even make a triangle, so we can cross them out. C. Construct the perpendicular bisector of segment AB. So we got segment AB. We construct the perpendicular bisector using our constructions. Mark the intersection of this line in AB and label it C. Draw segments AC and BC. Also doesn't make a triangle, so nope. Here we have construct a perpendicular bisector of AB. So we're starting again with AB. We drew a perpendicular bisector. Mark any point C on the perpendicular bisector. So let's mark this dude C, except where it intersects AB. So I can mark any point except for that point right there. Draw segments AC and BC. Now, based on our perpendicular bisector rule, we know that the points on a perpendicular bisector are equidistant to the endpoints of the segment that we just bisected, which means this segment is going to be equal to this segment, which makes this an isosceles triangle. So D is our correct answer. All right, let's go. Next question. Problem 5. Select all statements that are true about a regular polygon. Well, a regular polygon has 2 things that are true. The angles are equal and the segments are equal. Are all angles right angles? Nope. Are all angles congruent? Yup. Are all side lengths equal? Yup. Is there exactly 4 sides? Nope. Squares? 4 sides. A triangle's not 4 sides. You can have a regular quadrilateral or a regular triangle. There are at least 3 sides. Can we have a polygon that has less than 3 sides? Nope. So there does have to be at least 3 sides. And there we go. Problem 6. The diagram shows the beginning of a straight edge and compass construction of a rectangle. The construction follows these steps. So we did A and B, we constructed AB, we used a previous constructed to get a line perpendicular through AB passing through A, use a previous construction to construct a line perpendicular to AB passing through B, mark a point C on the line perpendicular to AB passing through A. Explain the steps needed in a construction. Well, we're going to need the line that goes this way, and we're going to need him to be perpendicular. So we're going to use a previous construction to construct a line perpendicular to segment CA through C, and it's going to look like this. Then we have this fun intersection right here. We're going to take this intersection, we're going to label him BD, and then the last step would be draw segments CA, AB, BD, and DC. And there you go, you have your square. If 3 sides are 90 degrees, the 4th side has to be 90 degrees. Problem 7. The diagram is a straight edge and compass construction. Is it important that circles with center B passes through D and the circle with center D passes through B? Show or explain your reasoning. So we have the circle with center B. He's this circle over here. Does it have to pass through? So he passes through. The edge of this circle is passing through D, which is over here. So is it important that they pass through each other? The answer to that question is no. It does not matter if they pass through each other. The only thing that does matter is that the circles are the same size, so they have the same radius, and that they are congruent. If you had 2 little circles that kind of pass through each other like this, as long as they are congruent, and we have those 2 intersections to draw a line through, which becomes our angle bisector, then that's totally fine. So in this case, B and D, those circles do cross through each other, but that isn't necessarily the case, as long as they are congruent and have some type of intersections. If they were so tiny where one was right here and like one was right there, there's no intersection, so that doesn't help us. So they just need to be big enough so that they have that crossing, and that would create the same angle bisector. All right, that comes to the end of our lesson. If you have any questions, please go ahead, put them in the comments below. If you like this video, make sure to like and subscribe, and I will see you next time moving on to rigid motion. Bye.